So when I do a speciation question, Millie, I use this plan, and I'm about to spell out the plan. The plan doesn't contain all of the dot points because it's a plan. Now I'm going to write down what I would write down if I was doing an essay about allopatric speciation. Okay? 1, we've got the original population with gene flow plus gene flow, and gene flow within the large population results in stable allele frequencies. Okay. The original source of that population will have variation. The original population will have variation, and the original source of all variation is mutation. So what is the definition of a mutation? Not a change. There's a word in a permanent change in the genetic code. If you leave out that word permanent, you don't get the mark. No half marks in year 12. Okay? A permanent change in the genetic code. If you've got a permanent change in the genetic code, what sorts of cells does it have to occur in to be passed on to the next generation?
Gametes.
Sorry?
Gametes.
It has to be in the gametes. So
Gonads.
it has to occur in the germ line of the gonads if it's to be passed on to the next generation. If it just happens in a skin cell, it's not going to be passed on to the next generation because skin cells don't give rise to your gametes. Okay. You're going to have overpopulation. There's going to be lots of individuals. And we also know that when you pass on your alleles to the next generation, the parental alleles are all mixed up, creating variation in the gametes. Yes? What are the two things that give rise to differences in gametes? Sorry?
Independent assortment.
Independent assortment and crossing over. When does crossing over occur?
No, protein.
Metaphase.
Metaphase 1. No.
Prophase 1.
That's what I said. I got it right.
Well done. Prophase 1 of meiosis. When does independent assortment occur?
Metaphase.
Metaphase 1 and metaphase 2. Okay? So we also have variation. We also have variation due to crossing over and independent assortment. Crossing over occurs in prophase 1. Independent assortment occurs in metaphase 1 and metaphase 2 of meiosis.
Isn't that just like already covered in the mutation? Because that isn't in
No, a mutation is a change in genetic code. The reshuffling of those mutations is due to crossing over and independent assortment. So make sure you cover the sources of variation within the population. So the original source of all new alleles is mutation, and the reshuffling of that genetic material so that every individual has new combinations of all of the new alleles is due to crossing over and independent assortment. Okay. Now, in macroevolution, we've got this GB and GI. GB means geographical barrier. Geographical barrier is a physical part of the environment that separates the population into two halves. Okay? The most obvious ones that are used are things like mountain ranges, oceans, rivers, something that species can't cross. The geographical barrier, and the geographical barrier leads to geographic isolation. Geographic isolation means that the two halves of the population are separated and can't contact each other. There's no gene flow. So this leads to no gene flow. No. Because there's no gene flow, they can't keep the stable allele frequencies. Differences are going to build up. Good? Do you understand that? Right. Now, so here, a subset has gone this way, a subset's gone that way. What decides which individuals go this way and what individuals go this way? Random chance. Well done. Random chance decides. And because random chance decides, the two subsets are not representative of the original population in terms of allele frequency. Okay?
Right, so random decides who goes on what side?
Correct. Random chance decides which individuals go in this direction, which individuals go in this direction. So the allele frequencies in the two subsets won't represent the original population. Okay?
Wait, can you just stop?
It's being recorded, so... All right? Now, because you've got a geographical barrier there, and the two groups can't contact each other genetically, there's no gene flow between them, they can't swap alleles. Yep. I've got DE means different environment. What is the environment made up of? Abiotic and biotic factors. B plus AB. The environments are different on both sides of the geographical barrier. Okay? Now, because you've got different biotic and abiotic factors, DSP means different selection pressures. There's going to be different questions posed on both sides of the geographical barrier. Now, the selection pressure might be predation, it might be camouflage, it might be access to water, it might be access to food, it might be access to shelter, but there are different selection pressures. Okay? There's different questions being asked on either side of the geographical barrier. Okay? Now, because you've got different selection pressures, will the answer be the same to different questions?
No.
And so what do we call that answer that is genetically inbuilt into the populations? Selective advantage. So because if you've got a different question, there's a different answer on both sides. So the question being asked here is different to the question being asked here. And because there's different questions, there's going to be different answers. And that answer is called a selective advantage. Okay? Therefore, different selective advantage. What gives rise to a selective advantage? What do you have to have?
Advantageous allele.
Well done. You've got to have an allele, a mutation that provides that advantage. So therefore, you're going to have different mutations building up on either side. The mutations that are building up here are going to be different than the mutations building up on this side. And that's what DSA means, is different selective advantage. And the selective advantage is a mutation. It is a change in the genetic code. So on both sides of this geographical barrier, the DNA for both populations is becoming more and more different. Yeah. You're good with that? Time. It takes millions of years for speciation to occur. It doesn't happen overnight. In fact, time is probably a bit of a misnomer because it's actually generations. It's actually the generational time. The quicker you reproduce, the quicker you evolve. So there are two things that drive evolution. One is the number of generations, because every time you replicate your DNA mutates. Yeah. So the shorter the time of your generations, the quicker your DNA mutates. And what's the other one? Changing in selection pressures. The more rapid the change in the selection pressure, it drives evolution. They're the two things that really count. If it comes down to the nuts and bolts of evolution, the more rapidly your DNA mutates and the more rapidly the environment changes, the more rapidly the species evolves. So it provides different variation, different questions, and because there's different questions, the answers are going to be different, and so the genes or the mutations that are created start building up differently over time. Okay? Right. So now 9 is when we've got, what did we talk about the other day when we spoke about small populations? What did I say? Every time you come across a small population, you need to talk about the chance of genetic drift. So in here, you could talk about genetic drift. Because we've got a large population up here, we've got small populations or smaller populations on either side of that geographical barrier. You could bring up the idea of genetic drift, which is random changes in allele frequencies over time. What drives genetic drift? SE?
No, SE.
SE?
Selection. Efficiency?
Sampling error?
Sampling error, thank you. The sampling error. And what does genetic drift normally lead to?
A loss in allele.
Loss of alleles and reduced genetic diversity. Okay, that's where you could put that in there. All right, then we can mention that here that different mutations have built up in the two populations. So they're genetically diverse now. Well, the two populations aren't similar because there's been no gene flow between them. Any individual from here cannot go over to here and take its alleles with it. There's no gene flow. So the two populations are becoming more and more different.
So now are they different? Are now they different species?
Well, they will be. This is what we're getting to. Number 11, we can talk about the idea of reproductive isolation. Do you remember what the definition of a species is?
Reproductively isolated.
That's one of the... You can't just jump to the middle of the answer. What's the first bit of that answer? A group of
Similar
in-
to a fertile environment.
a group of similar individuals that are reproductively isolated and can produce fertile and viable offspring.
Yeah.
Okay? Species can only breed with the same species. But because the two populations have such profound differences in their genetic code, their gametes can't come together to make a fertile and viable offspring. All right? We can say here, reproductive isolation means that it's only, a species can only breed with the same species. And even if they do manage to make an offspring, the offspring needs to be able to be fertile and viable. But because now there's so many mutations between them, because the two homologous pairs can't match up, you might end up with something that is viable, which means it lives long enough to reproduce, but it's most likely not going to be fertile. So it can't make functional gametes. And because of that, we say that does not occur. The offspring aren't fertile and viable. And because of that, we say that speciation has occurred. So here, we're going to have, we'll have population A or species A, and here we'll have species B. This is macroevolution. This has occurred above the species level. We can say that speciation has occurred because new species have evolved. So this is macroevolution.
Will one of them stay the same as the other?
Possibly, but unlikely. Possibly, but unlikely.
Okay. So they both form different species.
Well, the original population has formed 2 new species. It's divergent evolution. Yes, last question?
Allopatric speciation will always be macroevolution.
Yes, it has to be, because macroevolution is the creation of a new species. All right.
Say all